Hey guys, we're going to do a quick reminder over exponent rules. The first rule is the zero exponent rule. Basically, anything that's raised to the zero power equals 1. So if you have something like, 3x to the 7th, b to the 4th, z to the 10th, all of that raised to the zero power, that just equals 1. So anything raised to the zero power is 1. The power rules, that's when you're raising a power to a power. You take those exponents and you multiply them together. So for example, if you have something like x to the 7th raised to the 4th power, that's going to be x to the 7th times 4, which is x to the 28th power. The negative exponent rule says that if you have a negative exponent, if it's in the numerator, it goes down to the denominator and becomes positive. If it's in the denominator, it goes to the numerator and becomes positive. So for example, if we have something like x to the negative 3 over y to the negative 2, that would become y to the positive 2 over x to the positive 3. The product rule says that if you are multiplying two things with the same base, like in this case we have a, you'll add those exponents. So for example, if we have like x to the 5th times x to the 3rd, that would become x to the 5 plus 3, which is x to the 8th power. The quotient rule says that if you have the same base and you're dividing, you'll subtract those powers. So for example, if you have x to the 10th over x to the 3rd, that would become x to the 10 minus 3, which is x to the 7th power. Now notice that our highest exponent was in the numerator, so technically, our term ended up in the numerator as well. Let's say if we had like x to the 2nd over x to the 15th. We would subtract those exponents. It's always the top minus the bottom, and you get x to the negative 13. And remember, if you've got a negative exponent, it just changes places and it goes down to the bottom, and it has a positive exponent. Again, this was the higher one, so that's where it ended up. All right, let me move this up. Okay, lastly, we have rational exponents. Anytime you have a base raised to a fractional exponent, this is the way that we can convert it. So for example, if you have x to the 3rd power, and we're taking the 4th root of that, you could rewrite it as x to the 3/4 power. The numerator represents the power. The denominator represents the root. Let's see, if we had something like, y to the 7/3, we would rewrite that, or we could rewrite that as the cube root of y to the 7th power. All right, let's do some examples. Okay, these have the same base. They have a base of 5. I'm going to rewrite them with fractional exponents. So that could be written as 5 as raised to the 2/3 power times 5 to the 1/3 power. Now because these have the same base, you can add those exponents. So that'll be 2/3 plus 1/3, which is 5 to the 3/3, or just 5 to the 1st power, so 5. That's how that would simplify. On example 2, remember you're raising a power to a power, so you'll multiply those two. That becomes x to the 5/4 power. When you multiply 5 times 1/4, you get 5/4. And then you're multiplying that times, I'm going to change this to a fractional exponent, so 1/3, and that equals x to the a. So we're solving for a basically. So again, same base, and we're multiplying, so we're going to add those exponents. We're going to add 5/4 plus 1/3, and that's going to equal x to the a power. So if you're going to add 5/4 plus 1/3, you need a common denominator, which would be 12. I would multiply the top and bottom by 3, so this becomes 15/12. I'll multiply the top and bottom by 4, so this becomes 4/12, and that makes this 19/12. So x to the 19/12 equals x to the a. So in other words, a equals 19/12. All right, let's do a couple more. Okay, for these examples, I'm going to notice that I have this whole thing right here is raised to that negative power, and this whole thing is raised to this negative power. So I'm going to switch those locations in the fraction. That's going to become, let's see, we'll put the 2x to the fourth y squared, and now it's to the positive 3 power. The other one stays exactly the same because it wasn't raised to a negative exponent. All of that is over 6x cubed y to the negative 2 to the now positive 2 power. All right, now I'm going to go ahead and raise every powers to powers following my order of operations. So 2 gets cubed, multiply those exponents, and so that becomes x to the 12th power, y to the 6th power, and then that's multiplied times, remember this 2 basically gets distributed to each of those, so that's going to be 3 squared, x to the 8th, y to the negative 10th, and then all of that's over 6 squared, x to the 6th, y to the negative 4 power. All right, I'm going to work sideways now. So 2 cubed is 8. And let's see, I'm going to go ahead and take these numbers and multiply them together. So 8 times 9. And we have a base of x and we have a base of y. So my x's have exponents of 12 and 8. And since I'm multiplying, I'm going to add those exponents. So let me make that look clearer, sorry. So we'll add 12 plus 8. And then my y's have exponents of 6 and negative 10. And all of that's over. 6 squared is 36. X to the 6, y to the negative 4. Okay, that becomes 72 when you multiply 8 times 9. You've got x to the 20th power, y to the negative 4 power, all over 36. X to the 6th power, y to the negative 4 power. Okay, so let's do some simplifying now. If you'll notice, these y's have the exact same exponent. They're basically the same thing on top of each other, so those cancel each other out. You could do or show the work. You're doing y to the negative 4 minus the negative 4, which makes that y to the 0 power, which is just 1. So that cancels out and becomes the number 1. When you look at the 72 and the 36, those simplify to be 2. So this is going to equal 2. Then you have x with exponents of 20 and 6, so you're going to subtract those. So that becomes 2x to the 14th power. And that's my final answer. It's crazy that it became that simple. Okay, I'm going to erase all of this and do example 4. Okay, on example 4, if you'll notice, we've got this this particular expression is raised to the 0 power. So all of that just becomes the number 1 for that one. So we've basically got negative 4, x to the 3rd, y to the negative 1, all of that being squared times the number 1 over, and then I erased that, sorry, 2x to the 4th power, y to the 3rd, all of that cubed. All right, so let's work with that. I'm going to raise those to a power, so negative 4 is going to get squared. X cubed is going to get squared, so that becomes x to the 6, and then y to the negative 2. All of that over, everything on the bottom is going to get cubed. So 2 gets cubed, x to the 4th gets cubed, which makes it 12, because you multiply those powers, and then y to the 9th power. All right, let's simplify that. So negative 4 when you square it is 16, x to the 6th, y to the negative 2, all over 2 cubed is 8, x to the 12th, y to the 9th. And then simplifying that, these coefficients, the 16 and the 8, they're going to simplify to just be 2. You have like bases of x, where my exponents are 6 and 12, so it'll be 6 minus 12. And then you've got y, where you've got negative 2 minus 9. So that becomes 2x to the negative 6 power, y to the negative 11 power. And remember, if you have negative exponents, they change place in the location of the fraction. So that becomes 2 over x to the 6th power, y to the 11th power. And that's my simplified answer. Thanks, y'all.